regarding DC circuits, what happens is, look, engineer, what happens is that it takes a branch from these AC branches, which are the 3 phases, and then it goes into something called the battery charger. The battery charger, all right, great. So what does the battery charger do? The battery charger takes an AC supply and converts it into what? Into DC, into a DC supply. So it converts from AC to DC, meaning you could call it an AC to DC converter. Great, you told me that's very nice, and you understood with me, or you understood with me. All right, continue with me. When you exit from this, of course, it will be positive and negative, right? Positive and negative, exactly. It takes from there. These go here like this and enter here on the incomer and enter here on what? On the bus bar. And it starts to exit from this bus bar with what? Possibly with a miniature circuit breaker, depending, of course, on what? Depending on the loads you have. Exactly. It also exits like this with a miniature circuit breaker like this and so on. Engineers. It exits with such MCB or distributes depending on the loads present. Exactly. But at the same time, these loads that we will talk about here in the panel, at the same time, it also exits with an MCCB like this and goes to a set of what? Batteries. Exactly. This is what we call the battery. Here, this is what we call the battery. The bank of batteries you have at the station, meaning it took the AC, converted it to DC, charged its batteries with it, and at the same time, it supplies the control circuits and protection circuits you have. Well, Engineer Rashad, why did he do that? He did that, engineer, because in the case of the AC, if the station supply you are using to feed the substation service transformer goes out, all the circuits would go out, including the AC circuits, control circuits, protection circuits, and everything. But here, when you took it and converted it to DC, you took DC. You might say if the main supply also goes out, the primary one, the high voltage that you converted through the substation service transformer to low voltage here, if that voltage goes out, surely the battery charger won't output DC voltage either. I would say you are also correct. However, the idea here is that you have a backup system, not backup protection, because with DC, you can store it inside the battery bank. So if the main supply here is interrupted, the battery charger will go out of service and the batteries will directly start supplying the DC loads you have. That's great. Okay. Where is our camera? Here it is. All right, that's it. Engineers, very good. Now let's come to the DC circuit. The idea is quite simply that you have a set of MCBs. This is the same concept. It might not be an MCB. It could be a molded case circuit breaker. The purpose of the molded case circuit breaker is to take your DC and send it to the switchgear. You'll send it to a small distribution board specific to the switchgear and another one specific to the GIS and so on. All right then. Very good. Okay, and the problem is that the sound here. Okay, let's adjust the sound here like this. I come here like this. Okay, fine. Engineers, very good. So what is it doing now? Take note, DC takes for each cell. Focus here with me. This is not a loop like the AC. The AC would enter the first cell in your switchgear, and then from there to the next cell, to the cell next to it, meaning it enters with one source to a group of cells. Not every switchgear needs to be covered by the same AC. No. It could be that 5 cells are covered by the same source, but in the case of DC, it's not like that. So what's the situation? What you'll find is, look, this is the main, this is supply 1, and this is supply 2. Yes. So here it's coming from 2 different MCBs. One of them is supplying here, and the other one is supplying elsewhere. All right. And keep in mind, it tells you which is supply 1 and which is supply 2. So this one is from one source and this one is from another source, meaning both are not from the same miniature circuit breaker. And if you have 2 DC bus bars at the station, this could be from one bus bar and this from another bus bar. All right. And usually this is our case where the DC distribution board is like this AC distribution board divided into 2 buses. So you have a source here and another source there. All right. Now let's start by looking at your first source. All right. The first source is fine. And here it starts to come in like this, entering the terminal block called X427 of the slide link type. And it loops to the next terminal block X43 and something like 38. This feeds a circuit, and this feeds a circuit,
And the second disk that comes to you feeds 4 circuits that you have inside. All right, that's very good. Now, I'm done. I don't want to, or I'll go back to the presentation, or let me just stay here. It has what I want. Okay, so what will it start doing, engineer? Let's focus together. You have 2 circuits here, and you have 4 circuits. And okay, these circuits belong to you, Engineer Rashad. Let's see. He usually writes above in the scheme here what each circuit belongs to. As you can see, the first circuit is for the indication circuit, the second circuit is for the motor circuit, the third circuit is for the tripping circuit, and the fourth circuit is for the closing or control circuit. Then there's another tripping circuit and then a relaying circuit. So quite simply, if you want to know what each circuit is for, you have in the switchgear how many components? You have a breaker and an earth switch, right? Correct me if I'm wrong. Very good. Every breaker, engineer. What does it contain? It contains 2 tripping arc pin coils, a closing coil, and 2 tripping coils. Very good. So it has a closing circuit and 2 tripping circuits. Very good. Excellent. So what else do you have, Mr. Rashad? You also have for the breaker to charge its spring. So you have a motor. What do you have? You have a motor. So that's 4 circuits for the circuit breaker. As for the RS switch, all the operations we will see together are manual or mechanical, not electrical. All right, now for the next 2 minutes, what you have there needs power supply. So we call it a supply for everything related. And you also have a set, which has another circuit, of course. Here you have 6 circuits. All right, let's start with the first circuit we have, which is the motor circuit. The motor circuit for the circuit breaker, which I will start to sequence and explain. All right, the motor circuit here is seated and connected. If you come here, you will find the city dedicated to what? Dedicated to the motor circuit. So, what is this motor circuit, Rabba Shones and Rashad? Let's take a look together.